Today we can discuss on the new topic in thermodynamics, that it is entropy. Entropy, it's a new term. It's indicated by the letter S. Before explaining this term entropy, what's the connection of this entropy term with the spontaneity? And what's the purpose of this introduction of this entropy term in thermodynamics? That all the things we can check. Right? So in the last video, that means enthalpy and spontaneity, that video I explained there is a two driving force in spontaneous process. Driving force means, we discussed that the driving force means the force which is responsible for the spontaneity of a process. So we discussed two important points, that is, first one, it is in relation with energy, and the second one is in relation with randomness or disorder. Exothermic and endothermic cases, the energy relation, what's the energy factors influence on that particular type of reactions towards the spontaneous process we discussed. And on that time I said about that the randomness role towards the spontaneous process I will discuss in another video. I told like that in that. So that also I am going to be discussed in this video. So first we can discuss on the endothermic reactions case once again. In that video I said about that in the case of an endothermic reaction, you know that delta H, it is positive. So how that reaction it comes? Because of this product minus reactant. So that's why delta H, it is positive. From that you understood that the reactants, it is having the minimum energy compared to that of the products. Always we said about that one of the criteria for the spontaneous process to occur, it is the minimum energy attainment. So in this case the minimum energy attainment, it is not possible. The product, it is having more energy compared to that of the reactant. So always it has a tendency to form the reactants once again. So endothermic reaction, it is not following the first property, that it is minimum energy attainment. So then also I told about that this endothermic reaction, it is occurring. So how this endothermic reactions occur? How the naturally spontaneous reaction it is occur in the case of this endothermic reactions? Because of second factor, the randomness. Randomness, that's the second factor, is the reason for occurring this type of an endothermic reactions in a spontaneous manner. So we can check now. In the case of an endothermic reaction, you know that there is an absorption of energy, it is happening. Just imagine two reactants. It is for this reactions to occur, we need to be supply some energy. So that's why it is said to be an endothermic reaction. Absorption of energy, it's needed for that the reaction of these two components A and B. So due to that absorption of energy, what will happen? These molecules attains more and more energy. So what will be happening? The molecules in this beaker, if they attain energy, they collide with each other and they are suddenly moved to another places. So the movement of the molecule, the disorder of the molecule, the disorder itself we are telling the name is randomness. Randomness of the molecule, it is happening due to the absorption of heat by this reactant molecules. So disorder, it is increases. So due to that disorder, these molecules, it is because of absorption they received some energy, that's why they are having the disorder. So due to that disorder only that reaction it is occur and product it is formed, not because of the minimum energy attainment. So in this case of endothermic reactions, what's the reason for that reaction to occur? Because of this randomness or disorder. Disorder is the reason for occurring this particular type of the reaction. Because of the disorder attainment only, it is going to the product formation. Okay, so this is the one driving force for the spontaneous process. So first one, as we told, the energy, that is the correct reason for that exothermic reactions case. This energy, the minimum energy attainment, that it is possible for the exothermic reactions, so that it is having the role in the case of a spontaneous process. But in the case of an endothermic reaction, one more term we discussed now, the randomness. the disorder that is having the role for occurring that particular type of a reactions. Both this energy term, the energy decrease and the randomness increase, both are independent each other. Sometimes they will work together, sometimes independently they work together for occurring such a reactions. So either for occurring the reaction minimum energy attainment is needed, otherwise maximum randomness is needed. Then only the spontaneous or naturally occurring processes will occur. Here I written the same things here. Increasing randomness is reason for occurring this particular type of a reaction. So greater or maximum disorder is the reason for the spontaneous change for a particular type of a reactions. So in the case of endothermic reaction, as we already discussed, energy factor it's not favorable, but the disorder is a favorable thing for introducing the spontaneous thing. Okay. And so we discussed the term randomness or disorder. So the maximum disorder is the reason for spontaneous process. How much disorder it's there in this particular type of a chemical reaction, the degree of randomness or degree of disorder, how much it's there in the chemical reaction, that it is possible to find out with the help of one new term, that it is an entropy term. For that purpose, how much disorder, how much randomness it's there. For that particular purpose only, the new thermodynamic term, the entropy, introduced. Here one more example I shown here. This is one type of a particular arrangement. This is one type of, one place, one stopcock here. So here only one type of gas molecules here. Here after this cork, another type of gas molecules here. When you remove this cork, what happens? You can see here all the gas molecule, brown color and also blue color, both will be here before mixing. So after mixing, what will be there? It is going everywhere. So what's the thing you understood from that here? The disorder. When we remove this stopcock, at the same time the randomness, they are moving here and there, the randomness it is increases. Automatically they shuffled everywhere. So what's the reason for resulting such a product? The randomness is the reason. So for occurring this special reaction here, instead of decrease of energy, we use the term here in this context also the increasing randomness. Because of this increasing randomness, the molecules they shuffled each other and results one net product. So the randomness is the reason for this reaction also. As we discussed, so finding the randomness amount or a degree, we are finding the new term entropy. So definition, it is the measure of degree of randomness or disorder of a system. It is said to be the entropy. Yes, so it is one of the state function and it is an extensive property, and you just consider the gas, solid, liquid case examples. So here just assume this is a gas molecule. So you know that there is a lot of space between them, and just imagine this is a liquid molecule, so little space only between them, and this is the solid molecule, close packing arrangement it's there. So when we give little temperature or any particular thing when you given, what will be happening? When we give temperature to this gaseous system, the molecules receives energy and they suddenly move here and there, and faster movement of the molecules it will be occur compared to that of the liquid and solid. Solid, when we give the temperature also, they start to collide with each other. They have to be take much effort for occurring such a situation. So disorder, which one is having more? You can see that the disorder it is more for the gas. The disorder it is randomness, it is more for the gas because of the arrangement in the gas molecule. That is one of the important physical significance of the entropy. And we can say that entropy depends on the temperature. When temperature increases, automatically the entropy also increases. Then as we discussed, enthalpy change. Here also one more term we are introducing, the delta S, change in entropy, entropy change. Delta U we told, that is internal energy change. Delta H we told. Now we are saying about that the delta S, that is entropy change. Entropy change means, we discussed that before disorder, initially before, just to consider this is a system, when we give particular temperature, disorder will be increased. So initially how much the disorder, degree of disorder, that you can find out, and finally after getting temperature due to the disorder, how much degree of disorder it's there. Both disorders, when you know it, you can find out this change in entropy, that is as the entropy in the final state minus entropy in the initial state. Or in the case of, if it is in the case of chemical reactions, the product, entropy of the product minus entropy of the reactant, we can use it for finding the change in entropy. Then another important thing, entropy. Entropy change, there is a one relationship it's there for finding the problems. That is, we are when we consider the reversible isothermal systems. Isothermal system means that time temperature is a constant, right? So temperature constant at that particular situations, when we applying heat, you know that when the heat, if it is absorbed by a system, automatically entropy it is increases. So there is one relationship it is arising, delta S it is equal to Q reversible by T. Delta enthalpy change, it is inversely proportional to temperature, but enthalpy change, it is directly proportional to the heat absorbed or evolved. Yes, then unit, heat its unit it is joule, temperature it is, its unit is Kelvin. So here delta S, the unit of that delta S, it is joule Kelvin raised to -1 mole raised to -1. These are the some important criteria or important characteristics, not the criteria, characteristics of the entropy term S. Right, now we can tell about that. What's the due to this arrival of this entropy change in the spontaneous process, one of the new law in thermodynamics it is introduced, that second law of thermodynamics. Yes, before telling the second law of thermodynamics, we can tell some other things also, right? So here, isolated systems case. Isolated system case, here I explained one example. This is an isolated system. Why it is said to be an isolated system? Here, there is no exchange of matter and energy with the surrounding. If you consider this as a system, everything, the exchanging and the mixing, intermixing, everything it is happening inside this system. There is no exchange of energy with the surrounding. So no exchange of, so there is no exchange of matter or energy with the surrounding. That's why it is considered as an isolated system. So in such an isolated system, the spontaneous process, we are telling that the entropy change, it is a positive value. Why we are saying like that? Just come back to that, the same thing. So this is the before mixing and this is the after mixing. So you know that here the disorder it is less, that is initial state, right? This is the final state. So where is the disorder it is more? Here it is the disorder it is more. So what's the thing we studied? Delta S is equal to S final state minus S initial state, right? So S final minus S initial, here what will be the degree of disorder, it is here more, that means in the final state. So just assume if the degree of disorder, if it is 10 for this final state, surely the degree of disorder it is less for in the initial state. So just assume 5. So what is the value? It is a plus 5. This is just assumption values only. So positive value you will get. So if there is an entropy change, if it is a spontaneous, so we can tell about that. If it is a spontaneous process here, if it is occur, the delta S value, it must be positive. Positive in the sense, in mathematical way we can write it as delta S, it is a positive, greater than 0. Okay, so for a spontaneous process, if it is occurring here, so maximum randomness here, more disorder it is here. So that's why we are writing it as delta S, it is positive. This is in the case of an isolated system. If we carrying out the same spontaneous process when it is occurring in the universe in the sense, you know that it is a non-isolated one. That means the transferring of energy and matter with the surrounding, it is also possible. So such a situation when we consider that enthalpy change, if it is a spontaneous process, delta S value, that disorder it want to be greater than 0. So how it is possible? When we are calculating this delta S value, when you calculate the delta S of system first and surrounding next and add it together, that value it must be greater than 0. That value it is said to be the positive. Then only the process it is said to be spontaneous one in the case of a non-isolated system. So in the case of a universe, the spontaneous process it will be occur when we consider both system and surrounding. Their entropy value, the entropy change, it want to be a positive. Here I written entropy value positive means maximum disorder, more randomness it want to be. It's needed, then only it become a spontaneous process. So the total entropy of a universe, total entropy here is a universe. It must be increase in a spontaneous process. When it is increases, automatically delta S value it will be greater than 0. So with the help of this statement, we can say about that the second law of thermodynamics. What it is the second law? It states that the entropy of a universe increases in the course of a very spontaneous change. We said about that if there is a spontaneous change, delta it is greater than 0. So in the case of every spontaneous process, we can say if there is an entropy, if it is a positive, it is said to be a spontaneous change. If it is a spontaneous process, delta S it is a positive value. The reverse way only, we are saying the same, but we just changing the pattern of statement. It states that the entropy of universe increases. That means delta S it is positive. That is meant by the word the increases in the course of a very spontaneous change. That it is said to be the second law of thermodynamics. Okay, we can discuss now some problems. What is meant by the entropy increase in the case of a chemical reaction or decrease? If there is an entropy increase, surely it is a spontaneous process. So here, just assume this chemical reaction. In the reactant side, it is 2 and product side, it is 3, the moles. Okay, number of moles, you just calculate like that. This is 2 moles and here 2 plus 1, that it is 3. So, more number of molecule it is produced due to this reaction. So, that means you can see that the disorder it is increases when it is moving from reactant side to the product side. If there is a disorder, if it is increases, automatically we can say that the entropy it is increases in this case. Here also when we check, here 1 molecule of hydrogen reacts, it produces 2 hydrogen atoms. Right? So number of molecules it is increases when the reaction it is proceed. So disorder it will be increases when the number of molecules increases. Automatically we can say that the entropy also increases in this type of a reaction. One more example here I written now, that it is steam to water conversion. Steam to water means water in the gaseous state to water in the liquid state. Here number of molecules concept it will not be work here, but here disorder it will be work. This is in the gaseous form. Gaseous form it is having more disorder. When it is changing to the liquid form, disorder it is decreases. So what about the entropy? Entropy also getting decreased because of the disorder it is decreases. The order it is more in the case of liquid compared to that of the gas. So likewise we can predict about the entropy increase or decrease in each cases. Okay, thank you.